So we completed our SQL. SQL means the knowledge on top of relational database management system. The base has been covered. So you can just practice the thing as well as if any web is useful, you can also take the help from any other website. If you're quite interested with any other databases, you can also check it. Maybe in future, maybe in the same course, I'll be showing another database that is called Snowflake. Snowflake is a cloud-based database. So I'll be showing this kind of demonstration as well. Maybe mm, after 1 week or after 2 weeks, I'll be having a quick demonstration there. Okay. So we now I think we have the concept what database is. Database is just like storing the relational database. I just showed you in the last few days how MySQL database is storing the data in tabular format, how the database schemas looks like when we are going to create a table, how these things are going to be implemented and all. Okay, so this is basic small unit of a data engineering part. I mean, this is it is it is required for every field of data engineering, the SQL part. Okay, so today we'll be learning business intelligence. It will be there for 2 or 3 days. The course should be continuing for 2 or 3 days. And in this business intelligence, what we'll be going to learn? Actually, the main purpose of data engineers, what we have to do in the industry. Okay, the main end-to-end data flow from source system to target, how the data is getting represented, what is the purpose of data engineers and all those things we'll be learning in business intelligence chapters. Although it's not very much technical, we'll not be learning technical just like coding stuffs like SQL or Python, but the functional knowledge, the overview, why we are recruiting, what is the purpose of this thing, the entire view we'll be seeing in business intelligence classes. Okay, let me just go to the chapters. Okay, so business intelligence, I mean, in short form, it's called BI application. It's required in every field of data. So what BI applications do actually? It's an example on top of maybe a shopping mall industry. They are having different sales outlet. Okay, means different outlet counters are there. You can see in the pictorial diagram. This is one, first, second, third, three diagrams are there. So from all of the three diagrams, we are collecting data. Those are sales related data or any other data related to the outlets as well. Collecting the data and we are putting the data in BI application. And what BI application will do? It's very high level diagram. BI application will tell us the sales in the previous quarter. This kind of question. Revenue growth in past 5 years. Best selling product in each season. So this kind of question it can easily answer by the BI application. Now, how this kind of things can be done by the BI application, step by step, that things we will be learning. Okay, so this is called BI cycle. OLTP system will be also have some terminal. We'll be learning some terminologies. Okay, related to BI or business intelligence. The same terminologies will be used during during the project. So when you'll be live in a project, this kind of terms you will be you'll be learning there, you will be hearing there, and that is why please accustomed with these things and try to understand how the things are flowing from source to target. Okay, so this is called OLTP system, online transactional. Okay, we have the full form, online transaction processing system. Okay, OLTP. So OLTP systems, we can say that this is the source system of data for we are getting the data. Just like we have the example over here. So sales data means How the sales data is getting populated into OLTP system? Uh, there is various approach. Just like I told this kind of example as well. I mean, for railway booking, not sure. I mean, in India, you can see, if you can see the railway booking counter or just like this, they are using some mainframes. When we are, I mean, the passengers are telling the information, they're putting all those details in the computer, and in the databases, those things are getting saved there. The databases that we are talking about, this is a OLTP system. In shopping mall, they're using some software. Okay. So whatever bill or whatever things you purchase, the things are getting saved into a particular databases for further analysis purpose. So at the first time when they are storing the data in some databases, that is called OLTP databases or OLTP systems. There are various web application. Suppose some exam form is there. We are putting the responses over there, and they are storing all those information in the backend database. So these database can be our OLTP systems. Okay. But for the data engineers, we should not have to check how the web is working, how they're connecting with the databases, because our scope should be starting from the OLTP system itself. We need the data first in some of the source databases. That databases are called OLTP systems. So when OLTP systems are ready, data engineers will pull the data from the OLTP system by ETL tool. What is ETL? I'll be telling later. So this ETL tool will help to pull the data from OLTP system and push it into data warehouse. This is not a simple thing to design a ETL. I mean, this can be a different project as well. Okay, so when our data warehouse is ready, data warehouse is nothing but it is another kind of databases. OLTP can be a database. Data warehouse can be a database. In data warehouse, we are storing the data in tables, but those tables and these tables will be different. Okay, in OLTP, the data is stored in meaningless way. I cannot understand the thing. Means I cannot get the hidden pattern or hidden trend of the data or just like this. So by ETL tool, we are transforming the data in proper with the proper business logics and all, and we are saving the data in data warehouses. And we are making the data for reporting purpose. We are creating meaningful data in data warehouse. Okay. So when our data warehouse is ready, the reporting team or the visualization team, they will be creating charts and graphs on top of dashboards. Okay. So when the dashboards are live, then the end user or the strategy makers who are from the client team, they will be checking those dashboards and they'll take the decisions. Suppose their business is not going well for last 1 week. They can check these things from the report or dashboard. They'll identify what can be the root cause of this, and they can take the correct strategy. Okay. By checking this dashboard only, they can take the strategy and they will be implement the strategy in their business. They will be improving their business. So as soon as they will be improving their business, from the very next day, there should be changes in the OLTP system again. So when the data will be loaded again in the very next day at the data warehouse, at the reporting layer, the graph should be modified with the improved version. Okay, so this is the entire cycle. It's running and running. So this scope should be coming under data engineers, this ETL design or maybe the reporting design as well. Data warehouse design. So those scopes should be coming under data engineers. Okay. OLTP systems data population should not be taking care by us, means data engineers. That can be doable, maybe some ASAP developers, maybe some not Salesforce actually, maybe some web applications, maybe with the mainframe developers, or just like this. So they will be pushing the data over here. We should not have to bother how the OLTP is getting loaded. Our scope should be starting from OLTP itself. We will be connecting to this database and pulling the data through ETL tool. Now, what is ETL? ETL is abbreviation E for extract, T for transform, L for load. So the ETL is extracting the information from the source system. It will transform the information and it will be loading the final data to data warehouse. DW means data warehouse. Okay. So while loading the data, we follow particular rules to populate in the table. Just like it can be a fact or dimension. So today at the end of the course, I'll be showing what are facts, what are dimensions. And we need to also follow the normalization. Okay, what are normalization? Those things we discussed the second day, how the data can be normalized and all those things we learned. So will we follow the similar approach? The ETL2 will normalize the data. It will clean the data. It will try to implement all kind of business rule that is required, and at the final stage it will load the data in data warehouse. Okay, so this is the entire concept of BI cycle and the scope of data engineers. Okay, moving to the next step. Now I'll be just telling a few more things. What is OLTP? What OLTP is online transaction processing systems. Just like they are supporting, managing, facilitate, support operational or transaction oriented application. For example, banking transaction. So in a bank, there are credit, debit related transactions, daily basis, and those are getting stored into some databases. So OLTP can be, this is kind of OLTP database. Sales transaction in a retail store, railway booking and cancellation, all those things. So everything's, we are collecting the data and storing somewhere. So this is the transactional data. Those data is getting stored in OLTP systems in short form. It's called OLTP system. Now, what is OLAP? OLAP is online analytical processing system. So this is required for analysis purpose when our data is cleaned, when our data is transformed according to the business logic, and when our data is totally fit for the reporting layer. So before represent our data into reporting layer, we are telling this data set as online analytical processing systems. Okay, or OLAP. So OLTP is our source system, and we can tell OLAP is the final representation of the data. Okay. Now DSS. DSS means decision support system. So the people who are, this is not actually from data engineers. We are creating those dashboards, and after that, the particular people from the client itself, they are trying to figure out those questions to improve their business. So you can see those questions. What is the sales distribution region wise? How much profit does a particular product contribute? So the decision support system, they will be checking those questions from the KPI. KPI is one of the important term which is required especially in the dashboard side. Okay. So those can be important KPIs which they can get from the dashboard itself. Okay. So data engineers will prepare the data such a way so that dashboards can be easily create those KPIs. KPI, the full form of KPI is key performance indicator. We'll be learning the detail of KPI during the visualization tool learning part. Okay. Moving to the next slide. Okay. There is another kind of data representation. Just like this one, you can see this is the tabular representation of the data. And when the data is ready at the dashboard side, the data should be looking like in this way, the below chart. Okay. And the end user will be seeing or watching this kind of data at their side, the dashboard output. This way they can easily understand about all those parameters they are asking for. Okay. Okay. Now I'll be representing some flowchart diagrams where you can understand the entire flow. So the data entry operator or different transaction level of information are getting stored into operational database. This is nothing but the OLTP. And we should not taking care of this. There should be other developer who will be taking control of this thing. Okay. Other developer or other support member. Just give me 1 second. Okay. Now data engineers should, they will be taking control or taking care of this thing. Starting from here, they will be extracting the data during non-business hours. Why this thing is mentioned over here? So at the source system, this is our source system. Non-business hours means suppose a banking industry. Bank opens suppose from 10 a.m. at the morning time to 4 p.m. at the afternoon. Okay. So during this time, there should be heavy data flow in operational database in OLTP system. All the things are getting stored over here. So after 4 p.m., maybe there are some more transaction check clearance or just like this till 6 p.m. I'm taking this time 6 p.m. or 7 p.m. I hope all the banking related transaction directly from the branch. We are also doing online bankings and all that is, can be done at all the time. That is fine. But I'm taking consideration about the bank itself, banking branch. Okay. I hope all the things can be completed by 7 p.m. So operational database should be having less transaction or zero transaction after that time. So at that time during non-business hours, ETL job will be running. We are choosing non-business hours to reduce the load from operational database systems because some data is getting pushed over here at the same time. If we pull the data, we cannot get the exact picture what kind of or how much volume of data came to this OLTP system. Once everything is completed, we can choose some time and we can run this ETL job. This is nothing but the ETL job. When we are running the ETL job in a particular time, that time of instance, whatever data came to this OLTP system, that will be loaded into data warehouse. And specifically, it should be chosen at non-business hours so that there should not be any impact on OLTP systems, as well as we can get the correct data when the entire day's data has been loaded into OLTP. Okay. And this is called data warehouse. We'll be getting, more deeper things. What is data warehouse? When the data warehouse is ready, I mentioned that the report should be created on top of it. And the report will be refreshed daily basis because daily the new data is coming into data warehouse. Based on this thing, we need to refresh the report. If we refresh the report, the new data should be reflected in the charts and graphs. Otherwise, the graph should be static in nature. So every day new data is coming. Suppose we are creating some charts. There are x-axis and y-axis. The dependent data are getting displayed in y-axis. The independent data are getting displayed in x-axis. So you are having some line chart just like this. So today some new data came. So I need to refresh the graph's backend value. Otherwise, the graph should be static in nature. So that is why we need to refresh the report as well as soon as the data warehouse is refreshed with the new data. So this is the entire concept of data refreshing daily basis. And the manager means the decision maker, they will be checking the output of the report. Okay, till now any issue with the concept? Any issue? It's understandable for everyone? Any doubts so far? Any question? Any question from anyone? It's clear? Okay, I hope it's clear. If there is nothing, okay. Yeah, because it's clear for you. Thank you. Okay, now I'm putting some insights on top of data warehouse. Data warehouse is also, it's nothing but just like a database. We learned about MySQL database. So the similar, we can use another kind of database for data warehouse creation. It should be a database where we will be creating tables. Okay, the tables can be either a fact table or it can be a dimension table. What are fact dimension tables? We'll be learning these things at the end of today. Okay, but in data warehouse, the data can be stored in this way. Data warehouse can be a subject oriented data warehouse. It should be integrated in nature. Data can be time variant. So we have to store the historical information as well. We cannot delete the historical information. I can check the history data from there as well. Non-volatile. The data cannot be erased. Database should be highly available. So across all the region. So we need to choose such a data center and such a backup of storing the data such a way so that the data can be accessible at any places and that can be non-volatile in nature. That cannot be erased. It should be time variant. A data warehouse should be consisting data for a particular subject. Suppose I am storing data for a banking industry in data warehouse. The same data warehouse I am also storing the insurance related data. This is not acceptable. So based on a particular subject, the data warehouse are created. Okay, I'm just trying to display another flow diagram from source to target with some more detailing manner. Okay, let's check once more time. So the small boxes are OLTPs. Okay, OLTP system. So we are extracting the information with this blue color. The blue color arrow means the jobs, ETL jobs. Okay, ETL jobs cannot be stored the data in a single layer. It is having multiple layers. So first we are loading the data in a staging layer. Staging layer means it can be a database, it can be a file storing system just like S3 bucket. Okay. So this is called stage layer. In stage layer, we are not implementing any business logic. We are just pulling all the different source systems data in a single stage layer. Suppose in a banking industry, this kind of database is consisting, suppose debit related information. This database is consisting credit related information. Some other databases, those are containing some debit card, credit card related information. Some of the particular databases there trying to store the data related to some personal loan or any other, all kind of loan related information. Okay, maybe the databases is different. The first database, it's an Oracle database. This can be a MySQL database or just like this. Based on there, web application, how they can check the feasibility, they will be trying to create the database by their own. Okay, but from the data engineer's perspective, we need to pull all those data in a single layer because we need to set relationships between the databases. Okay, so that is why we are pulling all those information in a single stage layer. So nothing, no business rules are being implemented. We are just pulling one to one, maybe in separate table. We are storing the information in stage layer. When stage layers data loading is completed, again the ETL jobs are run. They're cleansing the data. Lots of bad data should be there. Lots of duplicate record can be there. So I think we all know how to do the normalization. How, at least we learn till second normal form in the second day of classes. So how to do those kind of transformation? We are implementing some business logics as well. So how to do that kind of thing that we'll be learning in transformation. Okay, we'll be transferring the data in proper way. Suppose, I mean, we can create a new columns as well. Suppose the new columns are not available over here. That can be some calculative column. As we learn in SQL, by using conditional statement, we can use some calculative column or derived column. So those kind of transformation we can do in this layer by the ETL tool. Okay, for the large scale of data processing, we are using this ETL tool. The similar kind of concept, whatever we have solved in our SQL classes, the similar kind of concepts can be doable by ETL tool. In the ETL tool, we can type customized SQL as well. Okay, or maybe this is a UI interface. We are doing some changes at the UI side. At the backend, they are creating those SQL. Okay, SQL syntaxes. So this is the way we are transforming the data. At the end, we are aggregating the data and storing the data, maybe in ODS, maybe in data warehouse, maybe in data marts. Any one of this thing should be a perfect OLAP analysis. All those three things will not be there. ODS is being used for the real-time data. Okay, data warehouse and data marts is the mostly usable things because all of the database is I'm not using the real-time data. Maybe as I mentioned, the data is getting stored in OLTP systems at the morning hours during the business hours, and data warehouse is storing the data during non-business hours. Okay, and the entire day is business transaction and get is in the it's getting stored in data warehouse or data marts at the end of the that particular day. Okay, so the business will be checking the dashboards and all. They will be checking at the morning time about the new businesses of the previous day's closure. Okay, but in ODS is consisting of real-time data, just like a streaming. Okay, operational data store. So some of the project, some of the critical business project, they are using ODS for their business purpose. So based on our project requirement, we can put either ODS or data warehouse. In the next slide, I have just given I gave some more details on top of ODS, operational data store. You can see ODS is a data store used to analyze near real-time data. So when things are happening, it's storing the same thing in ODS to solve day-to-day problem activities. Okay. There is data marts as well. Data marts are nothing but it's a miniature of data warehouse. So data warehouse is having lots of data over there. We can split the data across data marts, small tables to represent or to segregate the things in subparts. Okay. Just like over here is an example. A data warehouse contains data from multiple subject areas, just like departments in a particular organization. A data mart is a simple form of data warehouse that is focused on a single subject area. Suppose I'm creating data marts for sales, another data mart for finance purpose, another data mart for marketing purpose. Okay. So this is also a business choice whether I'll be using a single data warehouse or data marts. Here is an option for insurance data loading part. So over here we have a single OLTP system for insurance, but in an insurance company they are now covering multiple things just like property related data, automobile related insurance data, commercial insurance data. But at the stakeholders, they want the things should be segregated because the officers can be different and they don't want to have everything in the same dashboard. Maybe some security issue or maybe just like their policies and all. So they want to segregate the data in data marts and they are implementing security. Okay. So this way, just they are picking up property insurance related data and they are segregating this thing in property data mart by the same data loading part. This is nothing but the ETL tool, staging layer and everything they're doing and storing it in data mart. It's property related data mart. And the OLAP is created on top of it. Reports and graphs are created over here. Similar thing for automobile data mart, commercial insurance. So they're having a similar purpose, but the things are getting splitted. Maybe for the security implementation, they don't want to see one field's data to another one. Okay. Okay. Now I'll be giving you the concept. When storing the data in data warehouse or data mart, we are following the rule that the table should be either a fact table or it can be a dimension table. The fact table should be consisting of the fields. Field means the columns. Can be facts. Fact table should be consisting facts and dimension table should be consisting dimensions. So this is the way, ultimate way we are storing the data. We are creating the tables in SQL. I mean, the similar thing we have learned in SQL, we are creating the table with the create statements and all. Similar thing should be there in data warehouse, but we need to maintain lots of business areas. Data can be either facts, data can be dimensions. What are facts? Facts can answer your question how much, how many. So there are lots of fields available. Suppose employee name, employee ID, customer name, customer ID, customer address, customer city. Those kind of columns are available in data warehouse or maybe at the source system. But if I question on top of data how much, how many means who will answer? I mean the particular fields that should be coming under the numerical just like how much, how many that should be considering as fact. Okay. Just like here is some fields, revenue, cost, that all numerical data are called facts or it is also called measures. Okay. Number of accounts, all those fields are numerics. Just like employee ID, employee name can be a fact. It can't be a fact, sorry. So employee name is a dimension. Okay. But the billing related information, the bill amount, it can be a fact because it is the numerical data. So we need to identify what are facts, what are dimension. The facts are pushed to be fact table. So you can see this is a fact table. Sales table is a fact table. Billing table is a fact table. The red color highlighted columns are facts. Okay, sales, quantity sold, price, discount, all those things are called facts. And this is a fact table. Okay, in a fact table, you can see multiple keys are also stored. Date key, stored key, product key. Those are nothing but the foreign keys. There should be other dimensions available. In the dimension, suppose there is a date dimension. In the date dimension, date key should be the primary key. There is a store dimension. In the store dimension, store key is the primary key of that particular table. There is a product dimension table where product key is the primary key of that table. So fact table is consisting all of the dimensions tables foreign keys. Okay. Why we are keeping those keys? Just to establish relationship between all those dimensions. Tomorrow we'll be learning the data modeling part. There we'll be seeing why we are storing all the foreign keys. Those are called surrogate keys as well from each of the dimensions. We also learned this kind of concept in our second normal form in second day of the class. We are keeping foreign keys in a particular table so that we can set relationship between dimensions and fact table. Okay. Now what are dimensions? Dimensions, if we questions on top of data, who, what, when, where, whatever data or whatever fields we will be receiving at the end, those are called dimensions. Just like here is an example, customer, geography, time, those are all dimensions. Okay, so dimensions are kept in a particular tables that is called dimension table. Over here we have represented two different dimension tables, just like store, product, stored key. You can see all the store related information should be stored over here. Store key, store name, the particular street address, city, state, region, country. For the product, product key, product ID, product name, product group, brand, department. Now one quick concept I want to say over here. The dimension tables, though the dimensional table should be static in nature. As per the table, you can see, suppose I am the owner of a particular shopping mall. I have 10 outlets, 10 different stores in 10 different cities. Okay. So in the particular store table, there should be 10 rows or 10 record entry to represent each of the store. Okay. Similarly, maybe the product means in my shopping mall, how many different product are there? Maybe there are 2000 product. In all the shopping mall, I have total having 2000 or 3000 product. Distinct product, I'm telling. I'm not repeating same product. Means quantity, but there are suppose 2000 products available. Now you can assume that tomorrow I'll not be going to introduce a store, new store, or maybe entire 1 year I haven't introduced a new store. That means the table's data will be static in nature. Similarly for product, I'm not going to launch a new product in my shopping mall. So whatever the data was entered in, that was 2000, that is not going to be refreshed daily basis. So the dimension data, those are also called master information as well. Those are kind of static or very slowly changing. Okay, but the fact table, it is also called a transactional table. We are storing all the transaction related information, just like some billing, the invoice creating, all the things. The fact tables data can be refreshed, can be increased within a second. Okay, within a second, a new record is getting increased over there. The frequency of data refresh can be very high or fact table than that of dimension table, because daily basis, what are the transactions are happening, those field can be stored in fact only, not dimension. Okay, there can be few dimension which can be refreshed very frequently, but it is not just like a fact table. So that is why the row counts or record counts of the fact table is very high compared to a dimension. Okay. Suppose we have country dimension to represent all the countries' names and all. So you have a fixed number of countries in the world. So maybe if when we are not going to create a new country, till that time the country dimension should be having the same number of rows. Okay. So this is how the fact and dimension table works. Yeah, I think this is the last slide for today. Tomorrow we'll be trying to set up relationship between fact and dimension with the ER diagram, ER modeling, or it's called also the data modeling. Why we are setting up this relationship? We are setting up the relationship. Without this relationship, I mean, we cannot create the charts and graphs in OLAP analysis. Okay, so the relationship is been established because of this foreign key primary key combinations. So you can see in each of the dimension tables there are a primary keys are present, just like stored key. In the product table, product key is there. And the same kind of key is been pushed in fact table in my previous slides over here. In the sales table, you can see store key and product key are been introduced just to set up relationships between a fact table and dimension table. Okay. Just recall the things for the normalized form. It's the same thing. Data normalization. Okay. So tomorrow we'll be having some more insights on top of this as well as some ETL data loading strategy. Data extracting strategy, data loading strategy at the target side. Some more insights on top of fact and dimensions, slowly changing dimensions, grain and granularity of the fact table. So those kind of things or concepts should be clear in the next session. Okay. So till now, any doubt from anyone? Whatever topic we just covered for today, the functional understanding, is it clear for everyone? Some question it's clear for Kirti. I hope it's clear for other persons as well. If it's not, please tell me. Okay, I hope it's clear for everyone. So, okay, we are wrapping up this session for today. Let's connect on tomorrow to get some more insights on top of facts and dimensions. And I'll be requesting everyone to complete the SQL exercise that I provided the last working day. It's very simple, just like the previous day's one. So it should hardly take 10 minutes of your time. If you perfectly understand SQL part, then to solve the exercise, it should take hardly 10 to 15 minutes time. So please try to solve it. If you are stuck at any point, whatever you can do, just share me only that portion. Okay. Okay. Thanks everyone. Thank you. Bye bye.